This video is about the inverse trig functions in the context of right triangles. Previously, we used the fact that sine of theta is opposite over hypotenuse, cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent in order to determine the values of the missing sides of right triangles. But now, the problem we're going to work towards solving is determining the measure of the angle based on the values of the sides. Let's take a look at the right triangle with legs of length 3 and 4 and a hypotenuse of length 5. We don't know what this angle here on the bottom is, but theta is what we're looking for. We know that cosine of theta equals adjacent over hypotenuse. So in this case, 3 is our adjacent side, and 5 is the length of our hypotenuse. So we know that cosine of theta equals 3/5, which is equivalent to the decimal 0.6. We also know that the cosine of theta is going to be consistent for all angles of the same theta, regardless of how long the values of our sides of our triangle are. So we can now go to our unit circle and use 0.6 as our x coordinate, because on the unit circle, x equals cosine of theta. So here's 0.6 on the unit circle. Remember, the unit circle has a radius of 1 exactly. And then I just drew directly up from 0.6 on the x-axis to determine the point on our unit circle for which the x-coordinate is 0.6. So if you count off, this is 10, let's use yellow, 10, 20, 30, 40, and this one's 50. So this angle is just above 50 degrees. There you go, that's a little neater for you. Now, this method is nice for an estimation. However, we really want the exact value of theta right now. So what we're going to do is introduce the arc cosine function in order to determine the exact value of theta. Now, arc cosine is the same thing as cosine inverse. It's just another formal name. So if we cosine inverse of both sides, we'll cancel the cosine on the side with our theta. And we are left with theta equals cosine inverse of 3/5. We type that into a calculator and we get approximately 53.13 degrees. So once again, make sure that your calculator is in degrees mode and not radians mode. If your calculator was in radians, you would have got something like 0.927, which is not anywhere close to our estimate of about 53 degrees that we determined using the unit circle. One thing I want you to notice is that we wrote cosine inverse of cosine of theta, just like this. This -1 here does mean inverse and is not the same thing as the reciprocal. So make sure you don't confuse those two things. And just as arc cosine is the inverse to the cosine function, we have arc sine as the inverse to the sine function, and arc tan as the inverse to the tangent function. Equivalently, if sine of theta is equal to x, then that means theta is equal to sine inverse of x. If cosine of theta is x, then theta equals cosine inverse of x. And if tangent of theta is x, then that means that theta is equal to arctangent of x. So it's legitimate to say either. You can either say arc sine of x or sine inverse of x. They mean the same thing. They're interchangeable.